In this video, I'm going to talk on Unix file permission. The video belongs to Unix for Testers course series. Unix file permission. Okay, so whenever we hear the word file permission, what comes in our mind? So we think of security related aspects. Okay, so as I said, in Unix, everything is about files and processes. So files are used to store the data, then the data is processed with the help of processes, right? So that's it. Unix is all about files and processes. So if I want my system or my data to be very much secure, now in Unix case there are only two things, files and processes. So if I want security, then I need to apply the security related things on my file processes. Okay, so on files, what and all I can do on files, I can restrict, like if I can create if I can give some user access of creating or deleting the directories, or copying or moving or deleting the files, right? So I can give some access based on their roles, right? So that is about the files. About processes in Unix, there is like everyone will not have the access to start the processes, right? You need to give the access explicitly to specific user, right, to trigger the processes, to execute the processes, right? So that's how the security related concern gets handled in Unix, right? So it restricts the users by default not to uh, perform some operations like okay, so let us go into little details. So types of permissions for files and directories. Okay, so let me open my Excel spreadsheet. I can explain it better there. Give me a second. Okay, so let us say we have two things. We have files. Give me a second. And we have directories. We have two things, files and directories, where my data is stored. Okay, and there are three kind of operations which I can do. I can do read operation, I can do write operation, and I can do execute operation. So these are the three operations can be done. Let us see if I have, what happen if I have read operations on the file. Okay, so if I have read operations on the file, then you can look at the file content. Because you have the read access. If you have a write access, you can modify file content. And if you have execute permissions for that particular file, okay, then you can run the program. So why I didn't took uh, processes over here? Because in Unix, processes will get triggered via files itself. Like if I want to execute any shell script, basically that shell script is my file only. When I execute that shell script from that particular file, it will get converted into a process, right? So if I have execute permission on specific file, then only I can run the program. If I have write, then I can modify read. These are the basic things. So, fine. Now let us talk about directories. If I have read access to the directories, then okay, if I have read access, then I can to read the directories. What basically we do the command ls, right? So if I go to my particular directory, and let us say if I have read access to this particular directory, then I can do ls. I can get the list of commands, a list of contents in the specific folder. Basically, that's what I can just read the folder contents. That's what my read access is. Okay, and if I have write access to the directory, that means I can create new files, rename existing files, and delete the files, right? So I can create, modify, rename, and delete files basically, right? Because those files belongs to the folders, and I have directory is nothing but your folder only. So if I have write access to the directory, I can perform all these operations, right? And what else? If I have execute permission, then I can do basically cd on that particular directory, right? So see, let us say if I have okay, let me go to my WinSCP now. Okay, so in WinSCP, if I go to the root folder, okay, and in root my particular home is present in this home location and Prakash. Okay, so what I'm doing is I'm going in two folders detail. Like first I'm going into home and then I'm going to Prakash. So if I do not have the execute permission on this particular home, then I will not be able to open this home folder. Okay, so let us say for this RSA key or AC underscore Prakash, I think I do have access because I might have logged in via root. Fine. But if you do not have the write access or sorry, execute access, then you will not be able to see the content, right? Or sorry, not able to see the content, but not able to move to that particular directory. That's what I said. You will not be able to CD. You will not be able to change the directory, right? So basically there are three kinds of permissions, basically read, write, and execute, which we will be talking now. So, and in order to change the permission, there is some command called as chmod, which is change mode. Okay, and one more thing is okay, now let me go to my Unix. Now if I do ls, I get the list of files. Fine. Now if I want a little details, then what I do is I do ls hyphen l to get the details of the processes. Okay, so here you can see few columns. Okay, now what are these columns? So let me start for, say, I can take any file basically. Okay, so let me take this file basically, the second one. Okay, so you can see these details. Okay, so these are number of columns. So this is the very first uh, character, basically the very first position denotes or defines whether what is your basically a file type, whether it is a folder or it is a file. Or a folder is nothing but your directory. So if you see anything starting with D over here, that means it is a directory, it is a folder. And if you see hyphen over here, that means it is your file. Fine, so this is your first column. Now in second column you see something like rwx r hyphen hyphen something like that. Okay, so I'll talk about this in a moment. Fine. Then next we have the third column, which represent memory blocks basically. Yeah, it represents a memory blocks, how many memory blocks are utilized by this specific files or folder, whatever it is. Then this is my user, this is my user group, and this is basically the size of particular file in byte. Okay, so if you see in directory, they have the default size 4096. These two are the directory, that is the default size. But if you see the files, they have the size in bytes based on the content what they have in it. Okay, and then you have some data and all, and we have the your actual file or directory name. Fine. Now let us talk about these things. Okay, so let me just copy and let me paste it in notepad somewhere. Fine. So I just copied this. So as I said, there was one first character which was indicating what is your file type. Now the second, you can see there are total 9 bytes. Okay, so 3 bytes, and then you have another 3 bytes, and then you have another 3 bytes. Okay, so this first 3 bytes corresponds to user, second 3 bytes corresponds to user group. Okay, and the third 3 bytes corresponds to anyone else apart from user and user group. Fine. Now what they mean? So R is stands for read permission, W stands for write permission, hyphen means they do not have any permission, right? So what this mean is, if I talk about this specific file, okay, so to this specific file, uh, the first three bytes are for user. So for this specific file, the user have read and write access, and the third one is for execute. So the user has read write access but no execute access, and the second one I said user group. So next three is r hyphen hyphen, r hyphen hyphen. What this means is, the user group, anyone from the user group has only read access, no write and execute access. And last three bytes states that anyone other than your user and user group have only read access, no write and execute access. Similarly, if you talk about the directory, in directory, if you are a user, then you have all three accesses: read, write, and X means execute. Fine. If you are a user group, if you are a part of user group, then you have read and execute access, and anyone else also have read and execute access. Now this execute is nothing but simply you are able to browse or navigate to that particular folder, because in terms of directory, X is nothing but you are able to navigate to that particular directory. So I hope you are clear now. The first three bytes are for user, it states permission basically. Next three bytes are for user group, and next three bytes are for anyone else. Now, okay, as I said, three things: owner, group, and other. Okay, now let us take an example. Okay, so let us take an example of this file f1.txt. Okay, now what I want to do is, I want to change the file permission for this file f1. Okay, and as I said, we have command called as chmod, which is change mode. And to change the syntax basically for this chmod is, for owner there is some number, for group there is some number, and for other there is some number basically, followed by for which file or directory you want to change the permission. Okay, so fine. uh, Let me go to my notepad now. Fine. Okay, so let us say if you do not want any permission, like you do not want read permission, do not want write permission, do not want any kind of permission or execute permission, then basically your number will be 0. That it is basically a octal representation, right? You know octal code, 3 bytes basically, that's the octal. Then if you do not want, let us say, a read permission, write permission, and if you just want execute permission, then your number will be 1, something like that. If you do not want read permission, you just want write permission and do not want execute permission, your number will be 2. Okay, so basically your numbering will start like this. And let us say if you want all three permissions, okay, if you want read permission, write permission, and execute permission, your number will come to 7. Okay, so it is like, if you want only execute permission, number will be 1. If you want read permission, your number will be 4. And for write permission, your number will be 2. So based on this, for execute number is 1, for write number is 2, and for for read number is 4, and for write number is 2. Okay, so now what I wrote over here, like yeah, that's what I wrote over here, like your number is calculated like, for read there is 4 multiplied by 4, write corresponds to 2, execute corresponds to 1. Now I'll little bit simplify this. Let us say, my this particular file. Okay, uh, I have some file f1.txt. okay, and my this f1.txt file wants all three permissions: read, write and execute. Okay, so what number I have for read? For read I have number 4. For what number I have 2. For execute what number I have 1, that is 4 plus 2 6 plus 1 7. So for rwx I need to give 7. Okay, and we have three things. We have something for user, something for user group, something for anyone else, right? So let us say for user I want to give all three permissions, so I will give 7. Okay, and let us say for user group I just want to give the write access, so for here I'll give only 2. And let us say anyone else I do not want to give any access, so I'll give 0. So basically my number is turned into 7 to 0. Okay, so how this chmod commands works, basically it is chmod followed by your number. Now what is my number? My number is 720. What this 720 defines? 720 defines, okay, for this specific file, for this specific file f1 you are trying to set a permission 720, which corresponds 7 for user. 7 is starting first number in fact, so it first stands for user, second stands for group, third stands for anyone else. 7 stands for you want to give all three permission: read, write and execute. User group you want to give the write permission. For anyone else you do not want to give any permission. That's what it states. Now if I execute this command, okay, so for this f1 you can see currently it is rwrr. Okay, now if I execute the command what I wrote now, chmod 720 f1.txt, and if I do ls-l, I should see something different. Can you see? It is rwx and earlier it was rw, right? And for other it was r, but in other, in this case it is hyphen, that means no permission for other, right? So that's how you can give the permission. Fine. Okay, now there are some different ways as well, okay, how you can give the permissions. Okay, so okay, let us take another example. Let us say you want to read, write and just you want to do read and write, but the whole world you don't want to do that. Then in that case you will use, let us find it out. You will use what you want to just read and write, you want read and write, so in your case it will be 6, and the whole world don't want to do anything, so you will do chmod 600 followed by your file name. Now let us take an example. You want to read, write and execute, and the world, the rest of the other world don't want to do anything, so in that case you will use chmod 700, because 7 means all three permission for user, 0 means no permission for user group, 0 means no permission for the whole world. Okay, so basically these things are, see, this 7 means you can execute, so this 700 is this kind of permission is great if you are giving it to some script, because script is something which only I want to execute, right? So 700 is the best security permissions for scripts, right? Fine, let me tell you another way how you can give the permissions. Okay, so as I said, we have three things: user, user group and anyone else, right? So in short, these are termed as U for user, okay, and then G for group, okay, and then we treat as A for anyone else. Okay, so by using these short names, now U for user, G for group and A for anyone else, we will try to give the permissions. Now let us say chmod. Okay, now for this file 1, what I want to do is I want to, now this file 1 has write and read, write and execute permission basically for sorry, for user, right? So what I want to do is for user, so I want to perform action on user, so I typed u, and from user I want to remove the permission. So for removing I will use minus, and what permission I want to remove? I want to remove w and x permission from user. Okay, this u stands for user, minus or hyphen stands for removing the permission, and which permission you want to remove? W and x. Okay, and for which file? It is f1.txt. okay, it is executed successfully. Let us do ls-l, and this time you should see for file f1 you have only write and execute permission got revoked, right? So this is how we can use. Let us take another example. This time let us say you want to add okay, now this time you want to add what uh, all three permission to anyone else. Okay, so for anyone else what we have a. Okay, so for anyone else let us say you want to add all three read, write and execute. Okay, so a plus read, write, execute for f1.txt. okay, if I hit enter and if I do ls-ltr or l whatever, then for file f1 you should see anyone has all three permission rwx, right? So I did it only for anyone a. Okay, so that means anyone else, or if you just want to do it for other. Okay, so there are two different things, o and a. So this o means only last three bytes and a means anyone. Okay, so this is the difference. So let us say now from this file f1 you have all three permissions for everything. So let us say now you want to remove some permission from other, that is the last three bytes you want to remove, rwx, all the accesses you want to remove from other. So from f1.txt I'm done, and if I do ls-l and for f1 I should see all three accesses got removed from other. Right? So basically this is how you can you can use these short terms to give the permission. So you can do it in both ways. You can give it by numbers, or you can give it with this short abbreviations by using plus and minus. Again you can combine the two things, like if you want to, let us say, chmod. If you want for group, if you want, let us say in to the group, if you want to give read and execute access, and for other you want to only execute access. So if you want to do many things for the same file, then you can separate them by comma, you can execute, and you should see the things should get reflected as they want. Okay, so this is basically how you can manage the uh, Unix file permission. Okay, so that's what this is what all we saw. So let us take an example. If we have chmod 754, so this 7 stands for user, 5 stands for group, and 4 stands for others. Okay, so this 7 means all three permission, read, write, execute, 4 plus 2 plus 1. 5 means 4 plus 1, that means read plus execute, so read plus execute for group, and this 4 means only read permission for others, right? So this is how the Unix file permission get handled in basically Unix. Yeah, okay, so that's it. I have in this Unix file permission video where we mostly talked about this chmod command and why file security is important, and how this file security is handled with the help of this file permissions. Okay, thank you.